right, so a compound inequality. Is two distinct inequalities joined by the word and or the word or. Two distinct, it means like separate from each other. Two distinct inequalities joined by the word and or. So it's two different types of things there. Two distinct inequalities joined by the word and or the word or. So we're going to first talk about when these two distinct inequalities are joined by the word and. Okay? The and indicates that the inequalities are going to overlap. Okay, again, the word and indicates that the two inequalities are going to overlap. For instance, if you have x is greater than or equal to 3, let's make a number line underneath that. And we talked last week about how to show this on a number line. And let's make our number line from 2 through 7. Actually, I have room for 8, so I'm going to put 8 on there. As long as your next number line has the same numbers, it's fine. Okay. So when we have graphed this before last week, do you use an open circle or do you use a closed circle? Closed. At the 3, we have a closed circle because it can be equal to 3. In which direction do I shade? To the right. Okay. So this graph indicates that inequality. If we had another inequality, so remember we're talking about two distinct inequalities. If we had another inequality, x is less than or equal to 7. So again, I'm going to a number line that looks the same numbers as I have above. So you do the same numbers that you had also. Would this be an open or a closed circle? Closed. And this one I would shade to the left. So when we talk about overlapping, if we were to put these lines, my blue line and my red line, like together, what part would they have in common that was shaded in? 3 through 7. Okay, so in common they would have between the 3, again a dot at the 3 or a closed circle at the 7. That's what they have in common. So instead of writing these as two distinct inequalities, we could write it as one compound inequality where x is our variable. We have a 3 on one side, we have a 7 on the other side, and then we put our symbols in between like this. That would be a compound inequality that we use the word and for. Well, we would say x is greater than or equal to 3 and x is less than or equal to 7. And that's how we would write this. Yes. say that x is greater than or equal to 3 and x is less than or equal to 7. Or we could say that x is between 3 and 7 inclusive. Pretty fancy. Alright, so you can only write it like this if it is an and. You can only write it like this, where it's into one inequality, if you're using the word and. If you're using the word or, then you have to have them separated, okay? You can use the same number line, but you would have to have them separated. Let me show you one of the ones that would be an or, okay? So or means there would be, if you had like x is less than -2 or x is greater than or equal to 1, we could put this on the same graph. So thinking about my numbers here, I need at least from -2 to 1. All right, so I'm going to do -3, -2, -1, 0, 1. As long as you have from -2 to 1, you should have enough space. Now, just for sake of trying to make this a little bit easier for you to see in your notes, I know you're using only one color, most of you. But if I wanted to show x is less than -2, how would I show that on this graph? Open circle on -2, go into the left, okay? And if I wanted to show x is greater than or equal to 1 on this same graph, I would, at 1, good. So again, in our last example, we had an and because they overlapped each other, whereas this one is an or example because they're not overlapping each other, okay? The lines do not cross. Yes, it's another way of saying overlap. Okay, the next thing that we're going to do is we're going to write the inequalities. So if I said to you, all real numbers, and I'm going to use the variable in for that, that are greater than -2 and less than 6. Okay, that's going to be given to you. So if this phrase is given to you, we are going to write the compound inequality and we're going to show it on a graph. Okay? So let's first start off with writing this just as separate inequalities. So first of all, let's write all real numbers, and we're going to use the variable in, that are greater than -2. How would you show that? Well, don't we want our variable first? Okay, so all real numbers that are greater than -2. That's that part. Now let's do one for all real numbers that are less than 6. Wouldn't that be how it would look? All right. Now, so I don't mess anyone up, I'm going to rewrite this one because I want my n in the middle. So I'm going to rewrite this one. Notice my alligator is eating my n, so I want that same thing to happen when I switch it around. And now I'm going to make this combined. Okay, I'm going to take this one, and I'm going to take this one, and I'm going to do a mashup. Mashup. Mashup, like songs are a mashup, you know? A mashup. So I put them together, and there's our compound inequality. Okay? The next step would be to graph this, okay? So let's make a number line. Our number line needs to have at least -2 through 6. We need at least -2 through 6. I always like doing one more and one less. But you don't have to. As long as you have -2 through 6, it's fine. Are we going to be using open circles or closed circles? Open. Shh. Open at -2. And open at 6. And again, this is a compound. It had the word "and" in it, so it's only this area in between them. And this would symbolize all real numbers that are greater than -2 and less than 6. Everything in between here is greater than -2 but less than 6. Okay? Now we're going to do one that has an "or." I'm going to give you the words, then we're going to write the inequalities, and then we're going to show that on a graph. Here are the words. All real numbers. And let's use an "are" for this. That are less than 0 or greater than or equal to 5. Okay, all real numbers that are less than 0 or greater than or equal to 5. So because there is this key word "or," that means that we have to write them as two separate inequalities. We cannot do the mashup. We can only do a mashup if it's an "and." So for our first one, we're going to do all real numbers that are less than 0. So think about how you would show an inequality if you're using an "r" and a 0. R is less than 0. Yes? Okay. Now let's think about if we had "r" and it's greater than or equal to 5. Greater than or equal to 5. And I'm going to put in between these two things the word "or." Okay? R is less than 0 or R is greater than or equal to 5. We're going to put this on one graph. So what numbers do we have to have on our number line? 0 through 5. We need at least 0 through 5. Okay. So again, I'm still going to use my colors because it makes it easier for you guys to see. Let's do R is less than 0. What do I do for that? Well, hold on. Open circle. Which direction? Okay. And then R is greater than or equal to 5. Closed. Right. Good. Okay. Let's do step 2. Or the next part. Okay. What? No. -3 is less than or equal to m minus 4 is less than or equal to -1. We're going to solve this. Right, so write it down, please. So in order to solve this, we're going to write this as two separate inequalities. Right now, this is one of the ones where you have an and because it's a mashup, okay? But I'm going to take this part here. Negative 3 is less than or equal to m minus 4. I'm going to solve that. And then I'm going to take from here to here. M minus 4 is less than or equal to negative 1. And I'll solve that. Okay? So how would I solve this one in blue? Add 4. Thank you, Dawson. So, Dawson, what is negative 3 plus 4? Okay, so 1 is less than or equal to m. There's that one. And then over there, what do I need to do? Same thing, right? Uh-huh. So now that we've solved, let's do our mashup again. Caden. Well, normally I would say yes. He said switching your m to the right, or to the left, sorry, like switching this around. Normally yes, but we're going to put this back together again. So I want that m closest to each other, okay? So that when I put this back together again, I get 1 is less than or equal to m is less than or equal to 3. Okay? So once you kind of understand the concept, you really don't need to write it out separate like I did. You could just add 4 to that and add 4 to that. It makes it a lot easier. Question? This is an and because it's mashed together. An or is going to have two separate inequalities that have the word or between them. Like on my last example, that was our answer here, okay? Where we don't put those together. We can put it together on one graph, but we don't mash them together. This would be an or. That would be your answer. I'm sorry? Yes, you always graph. Closed circle. Closed circle. Everything in between there. Okay? Oh, I'm sorry. You're right. Good catch. You're right. Thank you. All right, I'm good. There is one other part, but I'm just skip it for now. All right, so this assignment is probably the easiest one I've ever given you.